Okay, so we're going to find the limit of this function f of x equals x squared minus 4 over the absolute value of x minus 2. The first thing with this is that we need to look at this absolute value in the denominator. So what we're going to do is we're going to break up that absolute value into two pieces, because really what that's saying is that it has a certain linear equation to the left of x equals 2 and a certain linear equation to the right of x equals 2. So to break that up, it's going to look like this. Let's see. So this equation is the absolute value function shifted to the right 2 units. We see that because it's minus 2 right here. So that means that to the left of 2, it's going to have a negative slope, and to the right of 2, it's going to have a positive slope. What that's going to look like algebraic or symbolically is going to be like this. So we've got our function is equal to, it's going to be two pieces. One in which you have the function where it's the negative value of that absolute value, and another where it's the positive value of that absolute value piece. I'm just going to put it in parentheses. Oops. Put it in parentheses. See if I can change that. Minus 2. Okay. This is going to be the function when x is less than 2. This is going to be the function when x is greater than 2. Okay. When x equals 2, the function is undefined. So the function does not exist at x equals 2. Alright, so let's start by simplifying both of these functions. Okay, so to start off, we've got x squared minus 4 over negative x minus 2. Well, that's going to be, you can factor the numerator, x minus 2, x plus 2, because that's difference of squares. And then in the denominator, we've got, I'm not going to distribute because I recognize that I can cancel out one of those factors right away. So I'm just going to leave that, x minus 2. And then right there, cancel out that. Excellent. Now we have x plus 2 divided by negative 1. Well, that's going to be negative x minus 2. Okay, so there's our first function. Okay, let's try and squeeze in the next one right here. We've got x squared minus 4 over x. Let's try that again. Oh, we have x minus 2. Well, again, that's going to factor into x minus 2, x plus 2. And yes, once again, those cancel out. Okay, so here we've got x plus 2. Okay, that's our second function. All right, now, so I'm just going to replace those in the numerator, in the piecewise function, second page. So we've got, let's try this again. F of x equals, I believe that was negative x minus 2 when x was less than 2, and x plus 2 when x was greater than 2. Okay? Alright, so now that we have our piecewise function, we can evaluate the limits that the problem is asking for. So it was asking for the limit as x approaches 2 from the negative side of f of x. Well, which function was that? That was, if we're approaching from the left, that's x is less than 2. So where is x less than 2? That's going to be this top function. So that's going to be negative x minus 2. And then for this we're just going to do the direct substitution. So we put in negative 2 into this function. We're going to get negative of negative 2 plus minus 2. That equals, oh, sorry. Let's try that again. We're not putting in negative 2. We're putting in 2 from the negative side. Okay. Minus 2, and that's going to be negative 4. So the limit as x approaches 2 from the negative, or from the left, of our function is going to be negative 4. And then over here, we're going to evaluate the limit as x approaches 2 from the positive side of our function. Okay, so then if we're coming from the positive side, we're looking for a number of values of x greater than 2, so we're going to use the second function here. We put 2 into that, and we get 2. We get 2. Let's try this again. We get 2. 2 plus 2, and that equals 4. Okay, so we have our two limits, left-handed limit and the right-handed limit. They are not equal. So what we can say is that the limit as x approaches 2, because the right-handed and left-handed limit do not agree, we can say that that does not exist. And that is our final answer.